So for the first part of this question, we're given a function, so cubic we can see, and we need to show that these are the first and second derivatives. So I'm just going to start by finding out what they are, term by term using the power rule here. Take out a factor of 3. Don't forget you can always use what you're trying to show as a clue about what you should be doing. That gives me x squared minus 4x minus 5, and then I just factorise this quadratic. To get 5, I can only have 5 and 1. I need to determine which one's positive and which one's negative. I need minus 4x, so that one needs to be positive, that's negative. That's what I needed to show here. For my second derivative, I'm going to use this line here because that's easier to do the derivative of rather than using the product rule. So this will give me 6x minus 12. I can factorise 6 out of that. And that's what we had to show. Now the next part says to find any stationary points and classify them. Remember that stationary points happen when the first derivative is 0. So we're looking at 3x minus 5x plus 1. Looking for when that equals 0. That equals 0 when either this one equals 0 or this one equals 0. So at x equals 5 or x equals minus 1. Now to classify them, we use a second derivative. So now the second derivative is 6 lots of x minus 2. I'm going to evaluate it at the first point, which is 5. And I see that that is 6 times 5 minus 2. I don't even really need to work out the answer. I see this is going to be positive. So I say this is concave up. And for the second derivative here, at minus 1, I've got 6 times minus 1 minus 2. And then I can see here that this is going to be negative. So it's going to be concave down. That means this is concave up, so this is a minimum turning point, and this one here is a maximum turning point. And we need to find points of inflection as well. They happen when the second derivative is 0, and my second derivative was 6x minus 2, so I set that equal to 0. That only happens when x minus 2 equals 0. That's when x equals 2. I must test it to make sure that the concavity is changing there. So I just do a really quick table. X equals 2, something smaller, something larger, just to see if it's going from positive to negative. I already know it's 0 here. Remembering that I'm looking at this function, 6 lots of x minus 2. So when x is 1, I've got 1 minus 2 is minus 1 times 6 is negative, so I'm concave down. And x equals 3. 3 minus 2 is 1 times 6, that's positive. It does change concavity, and therefore x equals 2 is a point of inflection. I need to sketch all this together. What I can see here is that I've got x equals 2. A point of inflection. I need to find the y coordinate for that. From the previous screen, I had x equals 5 and x equals minus 1. And they were minimum and maximum turning points. So let's just do some evaluations of that using our Gauss-span very quickly. We're looking at the function y equals x cubed minus 6x squared minus 15x plus 1. And I want to evaluate that. Firstly, when x is 5, this this is 99. The next one is when x is minus 1. The answer there is 9. And also for this point of inflection at the point 2, I get minus 1. So these are the points that I'm really interested in. And I can also see that when x is 0, my intercept is 1. It's got a cross there. I also know that it's a positive cubic, so I've got to have extreme values that do that. So at minus 1, 9, we have a maximum turning point. We've come up from the bottom, we hit this, we pass through here, we get over to here, that's the inflection point, 2 minus 1. And then I've got to head down to 5 minus 99, so it's going to be right down there. And then I'm going to continue onwards in that direction. And that's as good as a sketch as we can get for now. We can solve in our class pads for the roots there, so I might just show you how to do that. Take the question that we needed, highlight it, interactive advanced solve for x. If I had mine in decimals, if I change it to exact values, oh, it's messier. So I get a root of minus 1.95, that's this one here. I have another root at 0.064, that's this one here. And another root at 7.9 out there. Now it's pretty complete.